Yeah, microphone is on. You can hear me, right? Yeah.
Yeah, good afternoon, madam. Jai Sri.
Yes, sir. So you're joined?
Yeah, just now I
Yeah.
joined. Yeah.
Yeah. Okay, sir. Okay. 5 more minutes, sir. We will start, sir.
Okay, okay, no problem.
ಟೆಂಪಲ್ ಐತಲ್ಲ ಸರ್.
our faculty to do lot of research work in thermal engineering as well as the mechanical, even design, our faculty applications, digital manufacturing, research work, and engineering as well as thermal engineering as well as lot of design work, our faculty designs, our faculty research work, and lot of research work, and thermal engineering as well as lot of design work, and lot of research work, our faculty designs, lot of research work, and lot of designs, our faculty designs, lot of research work, and thermal engineering as well as our faculty designs, lot of designs, our faculty designs, lot of research work, and lot of research work, and thermal engineering as well as lot of research work, our faculty designs, our faculty research work, and lot of research work, and thermal engineering as well as lot of research work, and lot of research work, our faculty designs, our faculty research work, and thermal engineering as well as faculty designs, lot of research work, and thermal engineering as well as our faculty research work, and lot of designs, our faculty designs, lot of research work, and lot of research work, and thermal engineering as well as lot of research work, our faculty designs, our faculty research work, and lot of research work, and thermal engineering as well as lot of research work, and lot of designs, our faculty designs, lot of research work, and thermal engineering as well as faculty designs, lot of research work, and thermal engineering as well as our faculty research work, and lot of designs, our faculty designs, lot of research work, and thermal engineering as well as lot of designs, lot of research work, and thermal engineering as well as faculty designs, lot of research work, and thermal engineering as well as lot of designs, lot of research work, and thermal engineering as well as lot of designs, lot of research work, and thermal engineering as well as lot of designs, lot of research work, and thermal engineering as well as lot of designs, lot of research work, lot of research work, and thermal engineering as well as lot of designs, lot of research work, lot of research work, lot of and all other faculty, whoever is associated with this program. I wish you all good luck. Thank you.
Thank you, sir. Thank you for your
And all other
Indeed,
faculty,
it
whoever
is
is
a good
associated with this
book.
faculty, whoever
Now
is
I would
associated with
request
all other,
Dr. G.
I wish you all good luck. Whoever is
Srinivasan,
associated with us and all other, I wish you all good luck. And all other associated faculty, whoever is associated with all other, I wish you all good luck. Whoever is associated with faculty, whoever is associated with us and all other, I wish you all good luck. And all other associated with all other, whoever is associated with all other associated faculty, whoever is associated with us and all other, I wish you all good luck. And all other, I wish you all good luck. Whoever is associated with us and all other, I wish you all good luck. And all other associated with all other, whoever is associated with all other, I wish you all good luck. Whoever is associated with us and all other, I wish you all good luck. And all other associated with us and whoever is associated with all other, I wish you all good luck. Whoever is associated with us and whoever is
a program on tools for effective research in thermal engineering. The aim of this program on tools for effective research program. The aim dynamics, heat transmission, emission formation and surface phenomena, as well as the use of modern methods as pinch analysis, XSG analysis, emission formation, thermoeconomics phenomena, along as well as experimental use of modern methods formation, as pinch analysis, as well as from use of modern methods and road along as well as experimental use of modern emission formation, as pinch analysis, along as well as from use of modern methods and formation, as pinch analysis, as emission formation, along as well as from use of modern methods and formation, as pinch analysis, as well as from use of modern methods and along as well as use of modern emission formation, as pinch analysis, along as well as from use of modern methods and formation, as pinch analysis, use of modern emission formation, as pinch analysis, along as well as use of modern methods and formation, as pinch analysis, as well as from use of modern methods and formation, along as well as use of modern emission formation, as pinch analysis, along as well as from use of modern methods and formation, as pinch analysis, use of modern emission formation, as pinch analysis, along as well as use of modern methods and formation, as pinch analysis, along as well as use of modern methods and formation, along as well as use of modern methods and formation, as pinch analysis, along as well as use of modern methods and formation, as pinch analysis, use of modern
for the relentless support extended for this FDP. Now, without wasting time, let me take this opportunity to introduce the relentless person for the day, Dr. Gaurav Dwivedi. Now, without wasting time, let me take this opportunity to introduce the relentless support. Without wasting time, let me take this opportunity now to introduce the relentless support extended for the day. Without wasting time, let me take this opportunity now to introduce the relentless support extended for the day. Now, without wasting time, let me take this opportunity now to introduce the relentless support. Without wasting time, let me take this opportunity now to introduce the relentless support extended for the day. Now, without wasting time, let me take this opportunity now to introduce the relentless support. Without wasting time, let me take this opportunity now without wasting time, let me take this opportunity now to introduce the relentless support. Without wasting time, let me take this opportunity now to introduce the relentless support. Without wasting time, let me take this opportunity now to introduce the relentless support. Without wasting time, let me take this opportunity now to introduce the relentless support. Without wasting time, let me take this opportunity now to introduce the relentless support. Without wasting time, let me take this opportunity now to introduce the relentless support. Without wasting time, let me take this opportunity now to introduce the relentless support. Without wasting time, let me take this opportunity now to introduce the relentless support. Without wasting time, let me take this opportunity now to introduce the relentless support. Without wasting time, let me take this opportunity now to introduce the relentless support. Without wasting time, let me take this opportunity now to introduce the relentless support. Without wasting time, let me take this opportunity now to introduce the relentless support. Without wasting time, let me take this opportunity now to introduce the relentless support. Without wasting time, let me take this opportunity now to introduce the relentless support. Without wasting time, let me take this opportunity now to introduce the relentless support. Without wasting time, let me take this opportunity now to introduce the relentless support. Without wasting time, let me take this opportunity now to introduce the relentless support. Without wasting time, let me take this opportunity now to introduce the relentless support. Without wasting time, let me take this opportunity now to introduce the relentless support. Without wasting time, let me take this opportunity now to introduce the relentless supp Thank you so much.
one software which will be beneficial to everyone related to thermal engineering. One beneficial which will be to everyone related to thermal engineering. Beneficial to everyone related one software which will be to everyone related one software is beneficial which will be to everyone related one software which will be to everyone related one software one beneficial which will be to everyone related one software is beneficial to everyone related one software which will be to everyone related one software is beneficial.
We will discuss the response surface methodology, that is the part of the design expert software, and I have used in alternative fuel production and fuel character and the fuel property characterization. I have used the software. First, I am going to tell you something about this software. This software is very useful in optimizing the set of experiment. If you have 3, 4, or 5 or many number of parameters, then it is very difficult to decide the number of experiment. If you go by permutation and combination, the number of experiment may goes up to in thousands, 10,000 and lakhs. So it will be very difficult for everyone to perform all those experiments in the lab. So with the help of this software, we can reduce the number of experiment. The software will give the some set of 20, 25, 30 experiments, and that is very feasible by any MTech student and PhD student perform 25, 30 experiments in a lab during their program. So that is the one benefit, that the number of experiments are reduced. Second, the results, the accuracy of the process is very high. Third, this software is easily available. If you go for a trial version, you will get the 30 days and 45 days access. So within 30 days and 45 days, you can use it. And if you go for license version, you can. It is not very costly. It can cost up you to within less than 5 lakh for a institute can purchase that software. So, and it is very it is very easily to use. This software, it is not like some CFD or ANSYS. So I am going to discuss, I'm not going to discuss the theory of the software, and I am also not going to discuss about the methodology behind the software, how the software developed, how the mathematics is behind the software. What I am going to discuss, I am taking one of my problem which I have performed in the experiment, which I have calculated, perform all the set of experiment and got the result with the help of this software. And what was my experience? So I'm taking my one of my lab problem, and with the help of this software, I have optimized the biodiesel production. And what are the effects before in the total process? We are going to see that in the terms of development of alternative fuel, how I use this software on an alternative fuel, that I am going to show you. So with the help of that, you can also use this software in your own field. It is not limited to only alternate fuel or energy fuel or thermal fuel. It can be applicable in the area of the manufacturing. You can use it in the Taylor to life equation. You can use in any type of equation where the data parameter are available in large number. So first we are going in my presentation. First we are going to discuss about something, because I am related to mostly the energy field. So we are going to discuss about the something related to energy, which we will find very interesting. What is the energy scenario and why we are going for alternative fuel? What is the fuel for future? And what are the problem and bottlenecks we are facing in the area of the alternative fuel? We are going to discuss all those. Then we will move slowly to the literature review portion, where we will obtain all the data, and we will use all the literature review data and apply it in a design expert software. And with the help of design expert software, we will get the result. So it will be the lecture will be this whole presentation will be like application. It will not be like a theory of a software. So we are going to start it. So there are a few sustainable development goals. These sustainable development goals come from the conference of the party. All the countries have a conference of parties in the France, where they have decided that these should be our sustainable development goal for the world, and for the country level we have to fulfill all these goals. Like there should be no poverty, zero hunger should be there, good health and well-being. And out of this, for interest for the energy people like us, the affordable and clean energy come into the picture. Now, by 2030, we have to ensure universal access to affordable, reliable, and modern energy services. Then, by 2030, substantially the share of the renewable energy we have to increase in the global level. Again, by 2030, double the global rate of improvement in energy efficiency. Then by 2030, enhance the international cooperation to facilitate access to clean energy research and technology, including renewable energy, energy efficiency, and advancement in cleaner fossil fuel technology, and promote investment in energy infrastructure and clean energy technology. So India is playing a big role. India is combining with other countries and developing this type of global infrastructure at the world level. This word is international cooperation. So what India has done solar alliance. Started a solar alliance where many countries are joining us in the area of the solar energy. By 2030, expand infrastructure and upgrade technology for supplying modern and sustainable energy services for all in developing country, in particular least developed countries, small island, developing states, and landlocked developing countries, in accordance with their respective program of support. So by 2030, we have set some target related to our energy sector or renewable energy sector. You can say that. Now, what are the India's target? India has set the target. Like India want to reduce the emission intensity of its GDP by 33 to 35% by 2030 from 2005 level. 40% cumulative electric power installed jump from non-fossil fuel based energy sources by 2030. A jump of 33% over non-fossil fuel capacity by 2015. To create additional carbon sink. It means the carbon sink means we have to plant more trees. We have to cover more trees, up to 2.5 to 3 billion tons of CO2 equivalent through additional forest and tree cover by 2030. And for this, we have to expend a lot amount of money, and the amount will be USD 2.5 trillion required for meeting India's climate change actions. So to fulfill all this climatic action need, we have to expend USD 2.5 trillion. Now, what are the targets related to renewable energy? In the area of renewable energy, we want solar and wind energy to be increased from 4,060 megawatt and 23.76 gigawatt from 2015 level to 100 gigawatt and 60 gigawatt by 2022. And we are moving very fast in that direction. We are nearly achieving that solar and wind energy target. It is advised to increase the biomass installed capacity to 10 gigawatt by 2022 from the current capacity of 4.4 gigawatt. So in the area of biomass, we have set the target of 10 gigawatt. And then a special program to promote small and mini hydro project. New and efficient design of water mills have been introduced for electrification of remote villages and will continue to be promoted. Now, what is happening that in the case of large hydropower, when we want to develop a large hydropower, then the land area requirement, the ecology of that particular area will get disturbed. So the government of India is not promoting the large hydropower. Instead of that, they are promoting the small hydropower, which do not affect the environment and ecology of that particular area. So government is promoting the small mini hydropower. And what is meant by small hydropower? The power plant which are capacity of less than 25 megawatt are known as small hydropower. So government is promoting those type of plant. in the area of nuclear energy, we will be promoted from the current capacity of 5780 megawatt to 63 gigawatt by year 2032. Then we are one of the largest producer of the coal, but the issue is that the quality of our coal is not that much that we can use in our thermal power plant. So we have to import the coal from the countries like New Zealand, Thailand, and other countries. So in that direction, we are developing the clean coal technology, and with the help of clean coal technology, we are improving the efficiency standard, and then we are increasing the level of the coal so that it can be used in our thermal power plant. So we are working in that direction also. Now, if we talk about the bioenergy is the biggest contributor of the renewable energy source, according for about 12.8% of total. And biofuel is the largest contributor in renewable transport sector with around 2.8% of total. So biofuel is also contributing in the total transport sector in the renewable energy. Now, what is happening with our crude oil? We are importing large amount of crude oil from the other countries. Why we are importing? Because our domestic demand is very less. If you see up to financial year 20, it is very less, and we are importing large amount of crude oil, and this is increasing because we are not fulfilling our crude oil demand as per our requirement. We are not able to meet it, so we have to import. So to overcome this import, we can develop various type of alternative sources like development of alternative fuel, electric vehicles. There are many options. We are working on that so that this import burden should be go down. So in that direction, what Government of India has said that they have developed the national policy on biofuel, and the national biofuel policy has set some targets. What are those targets? The targets are like that. First is indicative target of 20% blending of ethanol in petrol and 5% blending of biodiesel in diesel by 2030. So this is the one target. Then with the thrust on advancement biofuel, the policy indicates a viability gap funding scheme for second generation ethanol biorefinery of rupees 5,000 crore in 6 years. Then categorization of biofuel. The categorization of basic biofuel, first generation biofuel, bioethanol and biodiesel, advanced biofuel, second generation biofuels, ethanol drop-in fuels, and third is algae-based third generation biofuel. So we have to categorize the various biofuel sources. Then increase the scope of raw material for ethanol procurement by encouraging intermediate sugarcane juices, other sugar containing material, and damaged as well as surplus food grain. This is very interesting. Actually, what happens, the ethanol source, the production of ethanol is from sugarcane, but there are other sources. So what government has said that waste food grain can also be used as a source for production of bioethanol. So now it can be used that this damaged and waste food grain can also be used. Then next point is development of national biomass repository by conducting appraisal of biomass across the country. Then biodiesel production to be encouraged from non-edible oilseeds, used cooking oil, short gestation crops, and other development of supply chain mechanism. So there are other various sources which can also be utilized for biofuel production. Then thrust on research area in the development of biofuel like biofuel feedstock production, advancement conversion technologies, and then last is setting up of National Biofuel Coordination Committee under Ministry of Petroleum and Natural Gas and Working Group on Biofuel. So these are some silent important features of National Biofuel Policy. Now, some people may ask that why vegetable oil, which we are using in our kitchen, can also be used for this as a development of alternative fuel. Now, if we use this vegetable oil as an alternative fuel, then there will be crisis regarding the food versus fuel. Now, issue is regarding that the domestic production of crude oil, you can see with the help of red line, it is going down, while we are importing large amount of this vegetable oil from other countries. So it means we are not dependent on the requirement of this vegetable oil by our own. We have to import it from other countries. So again, it comes the issue that it will create a problem, that food versus fuel crisis, if you are going to divert this oil for fuel purposes, and it also become very costly. So what we can do? We have categorized the oil which we are using for food purposes. We call it as a edible oil, and the oil which we cannot use for our food purposes are categorized as a non-edible oil. In edible oil, we can the canola, cottonseed, rapeseed, soybean, coconut, then mustard. There are various oils. We can categorize it in terms of edible oil. Then we have a non-edible oil like mahua and neem. Mahua and neem, both oils are non-edible, but mahua and neem have their medicinal uses. So we cannot divert it for this fuel production. Now we are remain with the Jatropha and Pongamia. Jatropha and Pongamia does not have very significant use. So these can be used as a biofuel crop in India. So Jatropha is the #1 crop in terms of the area wise and number of trees. Pongamia is the #2 crop. Now, why we are not using the oil directly for our engine operation? Oil should be used directly. There is why we are converting it into a biodiesel? This is the one question that comes into everyone's mind. Why it is necessary to convert this oil into a biodiesel? Why we are wasting so much time and money to convert this oil? Now, if you see the properties of all the edible and non-edible oil and compare with the petroleum diesel, now if you see the kinematic viscosity of, for study purpose, we have taken the edible oil only for study purpose, not for actual uses. Now, if you see the kinematic viscosity of the edible oil, it is all in double digit. Non-edible oil, it is all in double digit. While petroleum diesel, it is in single digit, 1.3 to 4.1. So the viscosity is 7, 8, 10 times higher than that of petroleum diesel for all the edible and non-edible oil. It means that if it is like using a curd or honey in for engine operation. If you use such type of oil which have viscosity like curd or honey, honey, then it will be very difficult for the engine to run. So it will result in engine choking. There will be blocking of fuel line, filter line, then damage of engine parts will be there. So we cannot use this oil directly for engine operation. So what we have to do? We have to reduce the viscosity. And how we are going to reduce the viscosity? We are going to reduce the viscosity by the process of transesterification. We are converting the oil into a biodiesel, and then only we can use it for engine operations. There are other properties which are also very significant. If you see the cloud point for edible, some edible oil, it is in negative, while for non-edible oil, it is in positive. Now, it means that the cloud point is also higher, means cold flow properties of where these oils are very poor. So, there it is another issue which we are facing. So, and if you see the cloud point of petroleum diesel, it is -15 to -5. So again, we have to bring down the cloud point to that level. The person who are very much interested in the area of alternative fuel or in the area of thermal engineering, they should know if they want to develop any alternative fuel. If you want to develop any alternative fuel, you have to compare that fuel property with that of the diesel, that is the commercial diesel. Only if your fuel standard meet the property of the diesel, then only you can say that my fuel will going to replace the diesel, or it can be used along with diesel. Now, This is the table for fatty acids. All the edible and non-edible oils are obtained from the nature. These are obtained from the plants. So they contain some type of fatty acids. Now fatty acids are basically categorized as the three types: saturated, and then saturated fatty acids, unsaturated fatty acids. Now how we are going to classify this? If there is no bond, if you see this table 12, 0, 14, 0, 16, 0, if there is no bonding is there, then it is called as a saturated fatty acid. If there is a single bond, then it is called as a unsaturated fatty acid. So if there is a single bond, it is called as a monounsaturated fatty acid. If there is a two bond, it will be called as a diunsaturated fatty acid. If it is as a three bond, it is known as a polyunsaturated fatty acids. So these are the categorization of the fatty acids. If there is we have to categorize it. If there is no bond, we can call it is a saturated. If there is a one bond, it is called a monounsaturated. If there are more than one, then we call it di, and it is more than up to three, then we call it as a three or more, we convert the polyunsaturated. So these are various type of fatty acid present in the oil. These fatty acids affect the property of the oils. If you see the percentage of saturated fatty acids is increasing for all the oils from 2.74 to 45, the oxidation stability and the cold flow properties are affected. With highest saturated fatty acid have very poor cold flow property. That means the mahua will freeze at the 41.2 degrees temperature. So it will be very difficult for using of mahua oil for engine operation. Similarly, for neem oil 36.08, it will be very difficult to use below the 27.1 temperature. What is meant by cloud point? It means that at this point oil will freeze. So if you are using the neem oil as a fuel source at 27.1, it will freeze. So you cannot use it for engine operation if the temperature is 25, 24 or 23. So we have to address this problem. Similarly, for stability issue, that it will not be stable for longer duration of time. 1 hour means 1 month. So some of the oils are not even stable for nearly 1 month. So how can we store for petrol stations? How can we will transfer this oil from the industry to the petrol station, then to the various vehicles? So if the oil is not stable, then we have to sort this issue out of regarding the stability and cold flow property. So we will discuss all these problem in another in coming topic. But now we are taking the Pongamia oil source. Pongamia is India's important 40 to this we have already discussed that we are importing 40 to 50% of edible oil of the domestic requirement from other countries. Therefore, it is not possible to divert the edible oil or for biofuel production. And then we have remained with the oil sources like Pongamia and Jatropha. And Pongamia is the drought resistant tree growing well in a marginal or poor soil. That is the one characteristics of the Pongamia. Now the distribution of the Pongamia worldwide, it is available in India, Myanmar, Philippines, Malaysia, Australia, Sicily, USA and Indonesia. Distribution in India is Andhra Pradesh, Odisha, Bihar, Jharkhand, Chhattisgarh, Madhya Pradesh, Karnataka, Kerala, West Bengal and Maharashtra. Mainly large number of states contain the Pongamia. Average seed 28 to 34% of oil. From the one seed you get 28 to 34% of oil. From one tree you will get 8 to 24 kg of seeds. And use of Pongamia oil, a small extent in lighting, soap making, medicine and lubricant. These are very small uses. It does not have any direct major uses. So this is the one reason that we are using the Pongamia as a biofuel source. if you compare the Jatropha and Karanja, Pangamia also known as Karanja, we are comparing the area of major tree for biodiesel production for Jatropha and Karanja. We can see that Jatropha is the number 1 crops in terms of the area wise, and Karanja is number 2. So these are the 2 non-edible oil crops, and the distribution is mostly in all the states of the India. Local name of Pangamia in various states like Andhra Pradesh, Ganok, Pongu, Karnataka, Honge, and in Madhya Pradesh it is known as Karanja or Karanj. It is usually known as Karanja, and there are various local names are available there. Now this is the data which I have obtained from the literature. Now the portion of the design expert which we are going to discuss, this starts from this table, and you have to focus more from this table. Till now we have discussing the introduction part. Now why I have to use the design expert software in this case? Now palmitic acid, stearic acid, oleic acid, these are the various acids present in the Pangamia oil. Now there are various literature available, various manuscripts available related to this Pangamia oil. Some have reported the percentage 3.7, some have reported in between, and maximum has reported 14.1. So I have put the range 3.7 to 14.1, minimum to maximum, all the range are covered. Stearic acid 2.4 to 10.9. So with the help of the from the literature, I have calculated the fatty acid range for Pangamia oil. This is the data obtained from the literature. And after that, I have taken the average that saturated fatty acid is 20.5 and unsaturated is 79.5. Similarly, I have obtained the properties of Pangamia oil from the literature and find out the viscosity. Minimum viscosity given is 27.84 and maximum is 38.2, which is 10 times, nearly 8 to 10 times higher than that of diesel if we are going to compare it. So this is the one issue. That's why we are going to convert the Pangamia oil into a biodiesel. So from this literature data, we find out that the viscosity is very high. We have to address this issue. Now, how we are going to convert it? There are various methods: blending, microemulsification, cracking, and transesterification. Transesterification is the very unique and simpler manner in which we are going to convert it into a biodiesel. We are taking the raw material, which is the vegetable oil, as a feedstock, and with the help of transesterification process, we are converting it into a biodiesel, that is the automotive fuel. Now, what is the transesterification reaction? We have triglyceride, that is the formula for oil, CH2O-COOR. We react it with the methanol, ethanol, the alcohol available with us, CH3OH, and then we have a catalyst to speed up the rate of the reaction, that is the acid or base, homogeneous, heterogeneous. There are various type of catalyst available. We can use the natural catalyst also. And after that, we are going to obtain two products. One is the mixture of methyl ester and other is glycerol. Mixture of methyl ester is known as biodiesel. Glycerol is a secondary product. The glycerol is used for soap making. By soap making industry, the glycerol is the basic constituent of the soap. So there are two products. One is mixture of methyl ester, that is the biodiesel used by the automotive industry, and glycerol used for the soap formation by the soap industry. Now, when I searched the data regarding the biodiesel production, how to optimize the biodiesel production, that my oil or my process will give the maximum yield. So I have done a lot of literature review, I have studied a lot of paper, and transesterification process have these very parameters very important. One is catalyst and its concentration. Second is molar ratio, what is the ratio of alcohol to oil, reaction temperature, mixing intensity, RPM, or time in hour. So these are the four parameters, and with we have to optimize the four parameters to maximize the yield. So I have studied various papers, and some have used KOH as a catalyst and concentration 0.25 to 1.5, molar ratio 6:1, reaction temperature 65, mixing intensity 600, and yield was not given. Some had directly used and yield was given 80%. So we studied various papers and find out that various type of yields were obtained with the help of same catalyst, different molar ratio, reaction temperature somewhat different, mixing intensity somewhat same, different in various cases, and find out that 95% yield, 96% yield was obtained. In some cases, 97% yield was also obtained. Now, then we have also used NOH, some have also used NOH as a catalyst, some have used H2SO4 as catalyst, and in the case of NOH, the yield was up to 99% in some cases. Then some have used the LiCO as a catalyst, and some have used sulfated zirconia as a catalyst. So various type of catalyst and their yield with the help of different molar ratio, reaction temperature, and mix intensity were obtained. So I have studied all the data. After that, I have purchased the oil and calculated the fatty acid with the help of GC technique. Now the calculated GC, this fatty acid composition, this is the calculated in the in the lab, and find out the saturated fatty acid and unsaturated fatty acid is 19.9 and 80.1. So this is the data of fatty acid which I obtained in the lab. The previous table which I have shown regarding the fatty acid composition was from the literature. Again, the fuel property, the calorific value is 29.9, which is way higher as compared to diesel, which is 1.4 to 4.1. This viscosity is very high, 49. Calorific value is low as compared to diesel. Viscosity is very high, and the stability is also not very good. Cloud point is also very poor. So we have all type of problem in the Pongami oil. So what we decide? We decide use to response surface pathology. Response surface methodology is a collection of mathematical and statistical technique useful for analyzing problem in which several independent variables influence a dependent variable or a response, and the goal is to optimize this response. So we are taking large number of variables, and with the help of large number of variables, we are going to optimize. Either we can do two things. Either we can maximize the yield or optimize the parameter. We can do two things. If you do not focus on the yield part, then we can optimize the parameter also. If you want to maximize the yield, then we do not bother about the parameter range. So there are various technique related to box Becken design. If the number of factors are there, then central composite systems will be like this. If there are two factors, then there will be 13, 3, 20, 4, 30. So you will understand this. What are this? If we are going to, when we are going for the experimental part. Response surface methodology explores the relationship between several explanatory variable and one or more responses variable. The method was introduced by GEP, Box, and KB Wilson in 1951. Use a sequence of design experiment to obtain an optimal response. In RSM, all the experiments are run to map the response to generate mathematical equations that describe how factor affect the response. So this is with the help of sequence or with the help of equation, we are going to solve the problem. Design Expert is a statistical software package from Statics Incorporation that is specially dedicated to perform design of experiment. Design Expert offer comparative test, screening, characterization, optimization, robust parameter design, mixture design, and combined design. Now, what is design of experiment? Design of experiment is a powerful statistical technique for improving the process design and solving process problem. A methodology to achieve a predictive knowledge of a complex multivariable process with the fewest acceptable trials. So we have to perform very few set of experiment and to get the yield and optimization of the experimental process itself. We can also do that also. What is the benefit? First, it reduces the time to design a new process. If you are designing a new process, design a large number of experiment, then with the help of design experiment software, we can reduce the time. If you have to perform like 100 set of experiment, so with the help of design expert software, we do not have to do hundreds of. You can perform the same. You will get the same result by performing only 20-30 sets of experiment. That is the one most important. It is time saving. Then it improves the performance of existing process. Perform evaluation of reliability and performance of the process. One thing here I have not mentioned, that it eases the error also, means the error percentage will go down with the help of the using software. Not only this software, if you are using any type of software, the chances of error will be very less. So these are the key terminology. What is the response variable, measured output value, factor, input variable, level, specific value of factors, continuous or discrete, replications. So these are the key terminology which will come into the picture. Now, what is the experiment design process? How you are going to do that? This is very important for MTech student, for PhD student, and even for the faculty. This graph is very, very important. First, we have to define a problem. What is our problem? Problem may be very big in nature, and it will be very difficult for an individual to address that problem. So what will he do? He will determine some objective. He will not solve whole problem. He will bifurcate the problem into 2-3 parts. For example, if you want to develop any alternative fuel, there will be a production part, there will be a fuel quality, and then there will be engine operation. So one student can take the production part, one will enhance the fuel quality, and third will see the engine operation. And they can also perform in a group also. So you have to determine some specific objective. After the brainstorming, you have to find out what type of experiment you can do. You have to design the experiment. After designing of the experiment, designing of experiment means the experiment may be software analysis, the experiment may be the experiment in the lab, or some experiment these days in the time of COVID, we can say some experiments are also be survey based experiment. With the help of survey, we are going to predict. Like people, with the help of various surveys, people are predicting the immunity level of the community, or predicting the number of the people infected in the society with the COVID. So all those studies are data-based studies. So this type of study can also be done. After that, you have to conduct experiment and collect the data. Now, if you are performing the experiment in the lab, you have to perform in a lab. If you are doing software, you have to do there. Or if you are collecting the data in the form of survey, you have to conduct experiment and collect the data. After collecting the data, you have to do the data analysis. What are the various points obtained from this study or experiment? After the data analysis, you will come to the conclusion of interpreting the results. So you will find out some result, and again you will verify the predicted result. If your results are in line with previous studies or not. If your study is very new, then also you have to see that your results are matching with the standard for that process, or a given standard, or various IS standard, ASTM standard. Your values are matching or not. So you have to do that. And this experimental design process is applicable for everyone who is working in the field of the science engineering community. He have to do like that only. If you are performing any experiment and analyzing the data. If you see this screen of the response FS methodology software, you will find out that central composite design, CCD design, then box beacon, optimal design, miscellaneous. We are going for the box beacon design. There is a one design called CC design. I am not going to discuss that. It is the old one. Box beacon design does not contain any embedded factorial. BBD has a treatment of combination that are midpoints. We are taking the midpoint value in the box beacon design. What is the midpoint value? You are going to see that in my design. I'm going to explain that. We have compared the BBD and CCD technique. BBD is better, less expensive to run, number of experiments are less. So this is the better as compared to previous one. Now, this is the setup for biodiesel production. If you want to produce biodiesel in a lab, this is the set. This is the biodiesel reactor filled with water bath, and this is the reactor. You have to put the oil, alcohol and catalyst in this reactor. Then there is a speed controller, then a temperature indicator. Then there is a stirrer. Stirrer will help us to rotate and mix the oil, alcohol and catalyst in this reactor. Then we have a condenser to control the temperature of that particular reactor. So this is the basic schematic setup for biodiesel production process. Now, this is the first table related to design expert software. When we install the software and design for biodiesel production, sorry, what we have to do. I have already told you that in biodiesel production process, that methanol, that is alcohol oil ratio, that is the one parameter. Reaction time is the second parameter. Reaction temperature is the third parameter, and catalyst amount is the fourth parameter. So we have put the symbol A, B, C, D for them. We can put any symbol. It is up to you. It is given in the blank in the design expert software. So you can put any symbol as per your convenience. After that, he will ask you for a range. What is the minimum value and what is the maximum value? So now people will wonder why I have written 3 and 12. Now I have shown you the tables of literature review. And in the table of literature review, I have compiled the data from the literature review that minimum methanol oil ratio was 3:1 and maximum was 12:1. So from the literature review data, I have put the minimum value to maximum value. Similarly, for reaction time, 30 minutes is the minimum level and 120 minutes was the maximum. Reaction temperature, 35 minutes was minimum and 75 was maximum. Catalyst percent was 0.30 is minimum and 1.5 is maximum. So I have put the minimum and maximum level. You can put your equation, you can put your parameter here, and you can also put your minimum to maximum value in this level, and you can put your own symbol. So just you have to replace this variable. You have to just replace the minimum and maximum value if you are performing in any other area. Now, when you put all this, then the table will generate. This table, this table is a continuous table. There are 29 set of experiment which we got from the response surface methodology. When we put this minimum to maximum value, the 29 set of experiment we are going to obtain. That if we are going for permutation and combination like 3 to 12 molar ratio, and if you are find out the number of experiment, then what will be 3, 3.1, 3.2? It is indefinite. Large number of experiments will be there if you are going by manual method. But with the help of software, we got only 29 set of experiment, and in the 29 set of experiment, some 3 or 4 experiments which are in repetitive nature to check whether we are perform that experiment in correct manner or not. So the 3 to 4 experiments are are of same values. So we have to perform only very few experiments in this process. So what we have done, we have taken the 3:1 methanol oil ratio. Reaction time we have taken 75 minutes. Reaction temperature 35. Catalyst amount is 0.9%. So we have taken all this parameter and performed the biodiesel production process, and we got the experimental response. Means we got the biodiesel production of 54.05. Similarly, we have for second experiment, we got 30.7. So for all the set of experiment, we have performed the biodiesel production process for 29 set, and we got the experimental response from the lab, that is the biodiesel production process, and up to 93.9, 71.7, 38.4. So we got the different set of experiment response with the help of different values obtained from this software. Now, when we got the this experimental yield, so yield is dependent on this equation. After that, we got this equation. So 70.58 plus 7.96 into A. What is the A? A is the methanol oil ratio. And then what is B, C, D? All the we got the equation in terms of A, B, C, D parameter. So what we have to do? We have to put this A, B, C, D value 375, 35, 0.9. So when we put 375, 0.9, all the value in this equation, we got the predicted response. So we got two type of response. One is the experimental response, which we got in the lab. Second response, which we got in the through the equation, that is the predicted response. So for the same set of experiment, we got two response. One is the experimental response and other is the predicted response. Both responses will be of different values, which we got through the Design Expert software. Now we have put this graph is automatically developed, predicted yield versus actual yield for Pangamia biodiesel. And now we have analyzed 3D diagram with the help of Design Expert software. We have analyzed 3D diagram, three-dimensional diagram for biodiesel production process. Now, if we see the time, if we increase the time, the biodiesel yield is also increasing. So if the time is increasing up to 75 minutes, the biodiesel yield is also increasing up to that direction. After 75, it starts 84, 93, 102, it starts deteriorating. So yield is start deteriorating after the 75. So this type of analysis we can obtain from this 3D graph. Similarly, molar ratio. In the case of molar ratio, as the molar ratio is increasing, yield is also increasing. Catalyst. So as the molar ratio and catalyst also increasing, yield is also increasing. Yield goes beyond to 100%. Now people will say that how can the yield goes beyond 100%? We have obtained one table of predicted response. In the theory, yield can go up more than up to 100% in theoretical response. In actual response, it will be less than 100 or up to 100. So similarly for time and temperature, we got the yield variation. Similarly for catalyst and time, so we can different set of graphs are obtained. Various type of graphs are obtained. Now, what is our target? What is our target in this experiment? Our target is, I have already told you, either you can optimize the parameter or either you can maximize the yield. So in my case, I have maximized the yield. I want maximum 100% biodiesel production. I don't worry about the parameter. So reaction time should be in range 30 minutes to 120 minutes. Methanol oil ratio 3:1, 12:1. Reaction temperature 35 to 75. Catalyst 0.30 to 0.90. These are my values and I want to maximize the yield to 100%. So after that, after putting experiment and predicted value, I got the final model validation value and final set of experiment. One final set of experiment. Actually, if you perform the experiment in Design Expert software, you will get the at least near about 100 solution. And out of 100 solution, you can choose any one of the solution as per your choice. So this is the one solution which is in range and meeting my criteria. So methanol oil ratio, if I take 11.06 to 1, reaction temperature 56.6, catalyst percentage 1.43, reaction time 81.4 minutes. I have to got the biodiesel yield of 100%. This is the theoretical value that I should got 100% biodiesel production as per theory. But when I perform, there may be human error, there may be instrumental error, there may be some error due to the quality of the oil or nature of the chemicals. So I got the yield of 98.4%. So percentage error is 1.6%. So this is the difference in the experimental and predicted yield. So with that, I can finally say that this type of result is obtained, that 98.4% of biodiesel yield with the help of design expert software is obtained. Now you can see how easily I have completed this process. Overall total process includes only working of 2 months. Within 2 months, I got this result, and this work is published in the Journal of the Fuel. So, which is very reputed journal in the area of the alternative fuel. So, with the help of this software, you can do similar type of work. After the biodiesel production process, the biodiesel that which we obtained, it contains alcohol. The boiling points of alcohol is 60 to 70 degree, and we do not want alcohol to be part of biofuel. So what we do, we put a heater, and this is the reactor that is known as a Bochi evaporator. So we heat the biodiesel, and the boiling, due to the low boiling point of ethanol, it's segregated into the another chamber, and then again it is very in pure form. It can again use for another process. So what we have done, we have obtained the Pongamia biodiesel, and we have compared the property of Pongamia biodiesel with some other fuels. We have property with the other fuels like diesel, ethanol, and kerosene. The kerosene for study purpose only. So you can see the viscosity. This viscosity is now in single digit, 5.76, and diesel is 2.46. So there is not much variation as previous one. So that's why we are converting the oil into a biodiesel. We have reduced the viscosity. Now it can be used. It cannot be directly used right now also. We have to blend it. So what we have done, we have prepared various type of blend. This is the PB100. PB100 means the pure biodiesel 100%. And we have measure the cold flow property, cloud point and pour point. It is higher. So what we have done, we have prepared different blends like PB20. That 20% of this is Pongamia biodiesel, rest is diesel. So the cold flow property improves. We have prepared with the ethanol. And when we mix the 100% biodiesel with the ethanol, that is PBE25, and ethanol is 25% and 75% is Pongamia biodiesel, the cloud points comes out to be 6 and 5. And the cloud point for diesel is also 6 and 5. So we can develop one fuel which will mixture of Pongamia and ethanol, and it has cold flow property similar to that of diesel. But the calorific value is on very low side. And now calorific value is on low side means you have to pay more for the same distance, because the energy for the same energy production you have to expense more fuel. So the people who are interested in the thermal engineering, for their information, except hydrogen, all other alternative fuels have lower calorific value than the conventional fuels, except hydrogen. Hydrogen has a very high calorific value, 2 to 3 times more than that of diesel. So except hydrogen, all other fuels have low calorific value. But the emission part, which we are in problem we are facing in the area of the Delhi and northern part of India, we have to compromise. We have to compromise this efficiency part. We are regulating various type of mechanism, odd, even. So for longer run, if you want to replace this conventional diesel, we have to compromise between the economy part also, because the alternative fuel will have lower pollution content as compared to conventional fuel. Now, what India is doing in the area of this conventional fuel, the alternative fuel, what India has recently done. India has low cost SpiceJet. It is operated country first flight using biofuel on 27 August. SpiceJet deployed a Bombardier Q400 on Dehradun Delhi route, which carry a blend of air turbine fuel 75% and biofuel is 25%. This is very interesting because they have developed the biofuel from the Jatropha, and the biofuel is locally developed by the CSIR and Indian Institute of Petroleum. The biofuel met the specific standard of the commercial applications, and such blend can be potentially reduce the carbon footprint by 15%. Then in the area of other area of the alternative fuel, Government of India has also developed several type of institute. I'm going to tell you about that also. Like we have a wind energy center at Chennai, solar energy center at Gurugram. Similarly, in the line of that, we have a small hydro center at the IIT Roorkee, which is working in the area of the hydro. Similarly, we have the Biofuel Research Institute. There's a Biofuel Research Institute known as Sardar Swaran Singh Biofuel Research Institute. It is at Kapurthala in Punjab. The people working in the area of the biofuel production, alcohol production, this as the alternative fuel, the institute is working in that direction also. Indian Railway has substituted this high sulfur diesel by methanol in the locomotive. Niti Aayog has directed Indian Railway to develop one dual fuel methanol locomotive. RDSO in association with the IIT Kanpur are working on the development of dual fuel methanol engine. So these are the various initiatives taken by the Government of India. Other than that, the Government of India has also given the incentive of this already told you, the development of the alcohol based crop with the help of the waste damaged food grains. So all those food grains are thrown away by the and or eaten by the rodents. Now they can be directly used for the biofuel production. And other than that, the government is also promoting the sugar based crop like the beetroot or other crops like corn crops, so for this biofuel production. And various countries like Brazil and USA, Canada, they are working in, they have already developed various type of engine which are working in the which are running on this type of alternative fuels. So what is the future scope? The future scope that Pongamia biodiesel should be used in neat form, that is the B100. I have already told you that we have used the blended form. When we use the blended form, we cannot predict the actual behavior of that particular biofuel source. So for development of any alternative fuel, you have to run the engine for longer period of time. The issue with our research system is that we want to publish paper as early as possible. So we are running the engine for shorter period of time. If you want to for longer period, if you run the engine for longer period of time, then only we can get the substantial result, and it can be used for the actual field applications. So that is the one future recommendation, that the future candidate should do the performance study of the neat clean biodiesel. Then what are the effects on the engine parts? Engine piston ring, piston cylinder, smoke emission may be studied in detail. The relationship can be developed between the percentage and saturation. What is the relationship between the various fatty acids and the fuel consumption? That can also be studied. So these are the some future scopes. In my lab, I'm working in the IC engine and fuel lab at Energy Center at Manit Bhopal. We have some opportunity for BTech internship available in the area of renewable energy, solar, wind, biomass. So you can apply 1 month to 6 month internship. MTech project work, you can collaborate MTech project work with us. We have 2 branches, MTech renewable energy and green technology. Both are admission through GATE. And then I have some PhD positions available with MHRD fellowship. You can apply with on the institute website for that. And my contact detail are these. For future collaboration, you can contact me. So we can work in the area of the alternative fuel. Thank you. Any questions? If you have, we can discuss. And
Yeah. Thank you, Dr. Gaurav Dwivedi. The session is open for questions.
Hello.
Hello.
Yes.
Yes, sir. Sir, good afternoon. Myself, Dr. Anand Gupta, is speaking from Odisha, IGIT Sarang, Indira Gandhi Institute of Technology, Sarang. So, actually, sir, you are talking about any software to optimize all the things. So, can you name the software, sir?
I have already told you that software name is Design Expert Software.
Design experts. Right.
If you search in a Google, you will get the latest version of the Design Expert software.
Yes, I know. Actually, I was doing in the mini tab. That's what I am. And sir, which optimization tool you have used to optimize?
There are various tools like CCD is there, Boxback and BBD is there. So as per the latest trend, you can use the BBD tool because it is the latest one. So you can use BBD technique.
Sir, what are the step-by-step procedure to do this BBD technique?
If you have gone through a PPT, first what you have to do, the BBD technique asks about the first, there will be some parameter.
Yes.
You are from mechanical field?
Yeah, sir, mechanical, and I have done research on the optimization also.
Okay.
And I know
now
all
you
the design area that you have taken DOE. I know that thing.
Now, if you take any equation, like if you take Taylor two-life equation or any other equation, there will be parameter. There will be like say 3-4 parameter, and first you have to identify the parameter, and then you have to find out the range. What is the minimum range to maximum range available from the literature? If there is no data in the literature, you can discuss with your guide and other peer, then what should be the range. Then you have to put some range value, and after putting the range value, you will get the set of experiment, and you have to perform those experiment physically in the lab. Once you get the result of the physical experiment, then you have put the value in the Design Expert software, then you will get one equation. With the help of that equation, with the help of the same data, you will get the predicted response. So there will be two response. One will be the predicted and one with the experimental. By comparing all those response, the software will provide you the there will be an optimization tool. With the help of that, you can either maximize the yield or optimize the parameter. So it depends upon you what you want to do. Either you want to maximize the yield value or you want to optimize the parameter. It depends on your objective. So after that, you will get the solution. At least there will be 70, 80 or 100 solution maybe there in the predicted form. And out of those, you can choose any as per your choice, and you can perform the another one set of experiment. And by performing that one set of experiment, you will finally validating that predicted response. And if the error percentage, I forgot to mention, if the error percentage is below the 15%, then your experiment is okay. If the error percentage goes beyond the 15%, then you have to perform again whole process.
Yes. That's right. Actually, I have done in the gray relation analysis and desirability index concept for optimization. I have not done for RSM. I was planning for RSM, and I don't know what are the different procedure to do the RSM technique.
RSM is very easy. RSM is very easy.
Okay.
You can easily learn. You can go through my paper. It there step by step is given there. So you can go through my profile and you will get one my paper. There are many papers related to this Design Expert software. If you go through one of my paper, everything is step by step given. So in one day you can understand what is the step by step of analyzing with the help of Design Expert software.
Right. Sir. Okay, sir. Thank you very much. If some collaboration will come, I will contact to you.
Sure, sir. Sure. Thank you.
Okay, sir. Thank you.
Sir, I had a question. Suppose say you said you'll get some 28 or 29 experiments. Right? So after getting experimental values, and then I will have the predicted values also, right? And then in many of your in the table, I saw even predicted values were less than the experimental value.
There may be what happens actually when it is due to the it is not on it is not value dependent on us. Experimental values are totally dependent on us. How we are going to perform the experiment, is there human error or the quality of the oil deteriorate. In my case, what happens, I have performed the experiment in the span of 3 months. So day by day, the quality of the oil changes. So that I have not considered in my study, that I have taken as an option, and I have mentioned that this is the we have performed this set of experiment in this period of time. So with that, there will be variation in the experimental and predicted response. In some cases, predicted response should be low. In some cases, it may be high as compared to experimental response. Some experiment are performed simultaneously, like two set of experiment are going on simultaneously. One, or either I perform one experiment in morning, one in evening. So due to that, there may be variation in the experimental and predicted response. That's why they have given 29 set of experiment. And if you go through the 29 set of experiment, at least 5 to 6 set of experiments are of same nature, means same values will be there. So, but with the experimental value or experimental result of all those experiments are not same. They are quite different because they are performed on different days and under different conditions.
Okay. And so how to, as Sir, Dr. Anand Gupta said, how to optimize it, sir? This is a common question many people,
then design experts, when we put all those values, design expert software will give the error percentage of overall your experimental and predicted response.
Okay.
If it has mentioned there, if there is an error less than 15% in total, then you are going in the right direction. If the error percent is beyond 15%, then you have to start the whole process again. Secondly, when you put the value, you will get various type of graph. There will be experimental and predicted graph. And in my work, if you go through this paper, they will find this regression coefficient and all other mathematical values, which I have not mentioned here because they are too cumbersome to discuss. The values of R square and coefficient of R and then logarithmic value, all those values are given there. And if you are going in the right direction, you will, if you have to compare with the previous study, or you can go through the software tool also, that it is in feasible range or not. Then you can proceed only in towards the optimization part. In optimization part, you will not get, I have mentioned only one solution. It is not like that there will be only one solution. There will be at least 70, 80 solutions. And out of those, you can choose one or two as per your convenience. And again, you have to perform the experiment. And then again, you have to compare your optimized result with the predicted result. And that is the final set, which you will decide that you are working in the right direction or not. If the error percentage again less than 15% or 10% as per your experimental total work, if it is less than that, then it is very good that you are working in a right direction, and you can say that this is the optimized result.
I think Sandeep sir, you wanted to ask some question? Somebody raised the hand.
Hello.
Yeah.
Yes, sir.
Sir, I have a question, sir.
Yes, sir.
Can I do full factorial design of experiments and then apply RSM?
Can you elaborate?
Like I want to generate equation between input and output parameters.
Okay.
And I do all the full factorial experiments. And is it possible to generate the equation?
First, in design expert, first you have to put the parameter range. After the putting the parameter range, you will get the set of experiment. When you perform the set of experiment, then only you will get the equation. So it is not possible to develop a equation without performing the experiment.
Like I'll be doing full factorial experiments, like all the possible ways of doing the experiments. After that, can I apply RSM? Is it not possible?
If you have experimental data, of that particular parameter, and if you are putting that experimental data in your experimental result column, you can generate an equation, and that equation you can use to predict get the predicted value from that equation. So if you have, but in my case, I have to perform the experiment because it was the case of biodiesel, or either if any person is working the area of the manufacturing, like in workshop, if he is working in the tool design, then he have to also perform the experiment. In some cases, might be if the data is already there related to some parameter, then you can do the theoretical process also. But till now, I have not done that. But it is possible.
Okay. So one more question, sir. I'll be getting one equation in using RSM, right? Can I use that equation to predict the output which is not in the range of input variables? Like
you can use that equation, but how much it will be authentic, how you are going to validate that will be the one question. Because if you after putting all your work in some manuscript form, when you are going to submit in a journal, the reviewer will ask you the question that why you are using that particular equation out of this particular range. Now you can do one thing. You can perform the design of experiment process. You can complete all your process. You get the predicted response, optimize that. You have done everything. Now, after that, you use that equation and you can use for some other parameter. Then you can justify that I have already done this work and this work is published. And now I am using that equation for this parameter. Then only you can use that and validate that.
Okay, fine. Thank you, sir.
So what in case if I am going with some new oil, I will not have data, then?
Then you can like if anyone says like algae oil are not very common. Oil, many people are using the algae oil nowadays. Now there is very less data is available on the algae oil. So what we can do, we can take the various non-edible oil data, like the case of Jatropha, Pangania or any other oil. We can take the data of those oil and put the range for the algae oil, and let's see how the production part go. If the experimental result and the predicted result have not much variation, then we are going in the right direction. No one will object about that. If there is very few range or few data is given there, we can do that.
Okay. And so for engine experiment, suppose if you think of applying this, so it will be a tedious task, right? There are so many parameters.
That's why very few people have actually this design expert software has also its limitations. I have not discussed about the limitation because we are discussing the application part. That's why I have not discussed the limitation part. The limitation part is that if the parameter are very large in number, then it is very difficult to handle that. In the case of the engine operation, the number of parameters are large enough. Then we have to go for CFD, ANSYS and modeling work. Then only we can. Then only it will be possible, and it is very tedious task. It will take 3 to 4 years for any alternative fuel for engine modeling and application part. And this software has limitation. We can use it for this biofuel production process, and also we can use it for quality enhancement. Like there are various fuel property which I have discussed briefly. In my next lecture, I am going to discuss about those cloud point and oxidation stability, how we are going to optimize those fuel property with the help of design expert software. That with the help of that we can apply the design expert, but in engine application or engine operation it will be very difficult.
Okay. Any other question? Any more questions? Okay, sir. I think no more questions. So once again, I thank you. Thank you for accepting our invitation. We'll again meet on 26th of November, sir.
Oh, okay. Thank you.
Thank you.
Thank you.
I thank you all the participants, and I'm sure, like me, you will have a good takeaway. The registration number we have already sent you.